The next presentation is about concrete overlays, and the speaker is Norbert Randl. He is full professor and head of the Civil Engineering Laboratory of the Carinthia University of Applied Sciences in Austria since 2007. He received his PhD in civil engineering from the University of Innsbruck, Austria in 1997. In 2001, he was awarded the so-called Liechtenstein Prize in recognition for outstanding scientific research in the field of concrete-to-concrete interface shear transfer. Being an active member of FIB and CEN, his main research interests include structural retrofit, high-performance concrete materials, concrete-to-concrete bond, and fastening technology. Welcome, Norbert. Floor is yours.
Hello, everybody. Thank you, Eduardo, for your kind introduction. Concrete overlays is a topic that one encounters in many different situations, actually. And I want, first of all, to guide to this topic where we have to deal with such detailed considerations of interfaces, and then we will also come to practical aspects. You can see here typical overlay applications. First of all, subsequent structural strengthening. In that case, the top surface overlay, which is, of course, the easiest way to place such overlay. But another topic we frequently meet is the completion of precast elements with cast-in-place concrete. This is a very similar topic to subsequent structural strengthening. There are, however, neighboring topics that are related to the concrete overlay. It is, first of all, the topic of construction joints, especially when you are not casting wet in wet, meaning if there is a pronounced interruption before casting the new part. Usually, when casting wet in wet, we assume a totally monolithic behavior. We do not consider this interface, but in case there is a pronounced interruption of several days, you have to take into account. Another topic that is linked to the overall one is adding new structural elements to an existing reinforced concrete structure. This is frequently done by means of post-installed reinforcement and also has to consider the load transfer via this interface. In this presentation now, we will focus on the structural strengthening. But many of the points we discuss here apply also to the other situations I just mentioned. The compatibility of the materials when doing such type of structural strengthening is one argument for strengthening with and retrofitting with a new concrete layer. Apart from that, such technique allows for a repair of a deteriorated old concrete surface. There are in general two basic methods. One is the top surface overlaying method, meaning increase of the thickness of a concrete member. So the main effect here is that we increase the effective depth of such concrete member. In the case of the bottom surface overlaying method, we add reinforcing materials embedded in the concrete overlay. And these reinforcing materials, of course, increase the bending resistance of the cross-section. Also, the inner lever arm is increased. Let's have a look at techniques and equipment. In order to achieve good bond, you need to prepare carefully the surface of the existing concrete substrate. That can, for example, be done by high-pressure water jetting or other methods like sandblasting. It is important to choose methods that do not damage the remaining concrete surface. In this context, milling is a process which enables a quick removal of the top concrete layer, but on the other hand, one should be careful when going for such load transfer via the interface. We must be aware that milling might also harm the existing surface. In these pictures, here you can see methods based on high pressure water jetting that are frequently used in practice. On the left-hand side, you see this hydro demolition with a hand lens. This was done close to our lab by a construction company in the frame of a research project we conducted together. But it's also a method that is used in practice on the site. On the right-hand side, you can see a robot driving with the truck here over a bridge deck and of course allowing for a high-speed hydro demolition process. Another special technique and equipment might be required when connectors have to be foreseen. Usually in practice, we go for good bond. That is very clear. But in various situations, you might be required to use connectors. It depends on the roughness. For example, if the option to roughen the surface is limited, or along the edges of such construction, of such structure, you might need connectors. I will come back to that topic. Or the load is just that high that you have transfer between old and new concrete layer that you, based on design, need such connectors. The connectors may be mere reinforcing bars or can consist of dowels, of certain headed studs, and so on. So there are quite many different kinds of connectors available. But also mere standard reinforcing bars are a possible connecting method. When setting such connector, it is of course a process that takes place after the old concrete already has been cast. So it's a subsequent installation of such connector in the old concrete substrate. From left to right, you can see here the process. This is a process as we did in the lab, but it's similar or equal in practice on site. So here, drilling the hole to a certain depth. Then you have to clean the hole. You inject the bond mortar, high bond mortar usually, and then you set the reinforcing bar or any other type of connectors. This is just an example of a possible process. Another important topic is the overlay concrete material. Usually we use ordinary concrete, meaning normal strength concrete, cast directly on the surface of the old concrete. But we have other options. We can choose high strength concrete, ultra high performance concrete, or also textile reinforced concrete. The latter one mainly on the tensile side, because we introduce with the textile reinforcement a very powerful reinforcing element. Concerning high strength concrete and ultra high performance concrete, an advantage compared to normal strength concrete is the high bond strength that we can achieve. Usually, with sufficient workability, you observe in a comparison between normal strength concrete and high strength or ultra high performance concrete, a bond increase of about 20 to 40%. So this is quite substantial. It also means that maybe you do not need a full roughening category very rough. Maybe lower category is already sufficient to achieve good bonding between this high strength, ultra high performance concrete and the substrate. Of course, we have also other advantages when using ultra high performance concrete. With its low permeability, it has waterproof properties, very high resistance against abrasion, and high durability and robustness in general. Just to show you a test result, which we did in our lab. You can see here a slab which we tested with a high strength overlay. And we compared the behavior of such overlay with a normal strength overlay. And you can see the difference here in the digital image correlation-based photographs. The normal strength overlay leads to a shear crack that follows here, as you can see, the interface. That is not always observed, but we observed this quite many times. Concerning the high strength concrete, we usually do not observe this phenomenon. We rather observe the shear crack passing without any deviation the joint, the interface. And of course, in small scale tests, you directly see the difference in bond properties. Now let's come to some design considerations. In order to perform a well-based design, you need a thorough assessment of the existing conditions. For example, detection of reinforcement. Service life means that you have to avoid delamination, because it's not just for the load-bearing capacity, it's also a matter of serviceability, whether the interface opens or not. Reliability requirements are usually not specifically different from standard RC members. We have various design approaches, most of them more or less based on the shear friction theory. like ACI code regulations or Eurocode 2. We also have in Japan the GCE guidelines. And then we also have the model code approach, differing between rigid bond and non-rigid bond slip behavior, where the reinforcement is activated. In that case of the reinforcement, also the interaction between tensile force and bending resistance of the reinforcement is considered in this recent approach. Concerning the full design procedure, we usually assume perfect bond and that cross sections remain plane after deformation. We have to consider here the loading history and have to differ between load deflection situation before and after hardening of the new concrete layer. And then, of course, the design of the interface shear transfer is a key task in that context. We have to verify what type of surface roughening is required, which category is to be achieved, smooth, rough, very rough, whatever. And then have to check whether connectors are required or not. The concepts between model code and Eurocode or also ACI code are very different, as Eurocode considers all effects together, meaning more or less plastic behavior of the connectors, and on the other side, full bond, which is differed in Model Code 2010. The detailing of the reinforcement is another specific topic in case reinforcement is required. If reinforcement is required, it makes sense to consider a minimum amount of reinforcement, because otherwise, when overcoming aggregate interlocking effects, the reinforcement will just shear off and fail. The distribution of such reinforcement, if required, follows the flow of shear force, and along the edge, one has to prevent peeling and delamination. Very simple models help to design the required force to prevent this peeling effect. Some aspects of execution. The thorough preparation of the surface is decisive for the achievable bond. You also have to investigate on site the degradation stage of the uppermost concrete layer. Here you can see from a case study provided in the according chapter in the FIB Bulletin, the placing of connectors and the overlay reinforcement. And this, of course, is then leading to the main topic of bond. You have to clean and to wetten the surface properly to achieve good bond. Usually saturated surface dry conditions are to be achieved. Quality control, this involves special activities in this context, like controlling the achieved roughness. One method widely used is the sandbatch method, but we have meanwhile digital methods, laser measurement, optical measurement devices that allow for production of digital model of such surface. The bond strengths can easily be tested via pull-off tests. However, one has to take into account that tensile bond strength is not equal to shear bond strength. We measure the tensile bond strength, but the shear bond strength is usually what is to be considered in design. This is here a full workflow, an overview of a workflow on a site in Austria. You can see here the whole process from roughening, setting of connectors, placing the overlay reinforcement, cleaning and casting the overlay. Thank you very much for your attention.
Thank you very much, Norbert, for this very interesting presentation. We have a question from Gassama Hem. He writes, hello, when you say surface roughening by high water pressure, what pressure level are you considering?
Usually we are talking about a pressure from 2000 bar to 3000 bar approximately.
Yeah, exactly. Thank you. There are no more questions. I don't know if the participants want to ask quite fast new question. Okay. There is another one from Tavon Kunsida that says, how about the existing condition of the concrete to be overlay? I imagine is referring to the substrate.
Thank you. It's also an important question. You always have to check the quality of the substrate concrete. It makes no sense to place a substrate on a highly deteriorated concrete substrate. So for sure, one first assessment and test to be done in advance is to check the quality and the deterioration grade of the existing concrete. Okay. Especially the surface has to be investigated. And when you do the casting, or let's say before doing the casting, you should wetten the concrete, but you should not have standing water on the surface. This is neither good.
Thank you, Norbert. There is now a question by Frank Papworth. He's asking if you have any recommendations on bonding aids.
On bonding agents?
Aids. You can check also in the Q&A window on bonding aids.
Yes, yes. Usually, I would not use any additional bonding agents, or I don't see necessity to use anything in addition, but cleaning, roughening, or let's say the other way around, roughening appropriately the existing concrete surface, and then cleaning and wettening. As far as I observed, and also many other colleagues observed this, if you use any additional bonding agent, it does not really help. In some cases, even reduce the bond properties.
I think roughening is the best approach.
Yes, absolutely.
There is now a comment by Tavon Kunsida. In some cases, there are many crack or other damages. I
assume it is meant concerning the substrate, probably, or maybe not. We can afterwards discuss. I mean, it depends always on the type of cracks that are observed. And as I said, you have to assess, first of all, the quality of the substrate and have to judge, of course, the crack patterns and the stage of deterioration of the substrate, of whether or not it is possible just to do, for example, high demolition and then cast a new overlay on it.
There are many more questions. I will try to keep the schedule. If there are unanswered questions, Norbert, please answer in the Q&A window. You can write the answers. There is another one by Maynard Oliver Gonzalez. I think is referring to how to design the shear friction reinforcements at the surface between old and fresh concrete. I think you will refer to FIB Model Code 2010. So I will skip this one. And another one, again by Frank Papworth, is asking if you recommend pull-off tests or any other test on the base before laying the overlay. Sorry.
Yes, Frank is absolutely right. I would usually recommend doing pull-off tests if for some reason you have the feeling that the old concrete surface might be deteriorated. So it makes really sense to do pull-off tests also on the substrate, just to check the state of the top surface.
Okay. One last question by Maria Kierczek. She's saying that placing many layers of UHPC, what must be considered when preparing the interface between different UHPC layers? Roughness, bond between the layers, risk of delamination.
Well, I would say, when I understand correctly, when placing several layers of UHPC, then of course, if possible, you should try to do wet in wet, meaning directly on a not yet fully hardened UHPC, and that provides best bond. If you have a hardened UHPC layer and put another one on it, then it's different, and then you should somehow achieve a rough surface, which is, I can imagine in that case, difficult if you really need various layers.
Okay, Norbert, thank you very much once again for your presentation and for answering all these questions. I give now the floor to Eduardo Cavaco.
Thank you. Bye-bye.